This is the brief on solutions to the one-dimensional wave equation. So we're zeroing in on the math behind how wave pulses move in a single dimension. You know, how they travel, how they hold their shape, and how they resolve themselves. It's actually fundamental to a ton of stuff, like how sound travels, or even how electromagnetic signals work. Okay, first up, the core math solution says the wave is a traveling function. So what does that actually mean? It means the wave shape stays perfectly the same as it moves along at a constant speed, c. But here's the kind of counterintuitive part. The math forces the direction to be the opposite of the sign in the formula. So if you see a plus sign, the wave is actually moving left. A minus sign means it's heading right. Second, because of this whole constant shape thing, we get this idea of superposition. Basically, the wave equation tells us that any solution is always just the combination of two separate waves. You've got one profile that's always moving left and another that's always moving right. So no matter how messy the initial pulse looks, it's really just those two simpler waves added together. And finally, let's picture this. Say you create a pulse right in the middle and you release it from a dead stop, so zero initial velocity. Well, it doesn't just sit there. The pulse instantly splits into two component waves. And get this, they're identical halves of the original, and they just immediately start racing away from each other in opposite directions at that constant speed, c. So the 1D wave equation shows that any initial disturbance instantly splits into two unchanging profiles, both moving in opposite directions at a constant speed.